Let's consider the steam-to-water heat exchanger as shown in the following figure. Under minimum load conditions, the size of the heat exchanger is such that it heats the constant flow rate of water from 60 degrees Celsius to 65 degrees Celsius, with a steam temperature of 70 degrees Celsius. The controller has a set point of 65 degrees Celsius and a proportional band of 10 degrees Celsius as shown now on screen. Let's now consider a sudden increase in the water load, such that the returning water temperature almost immediately drops by 40 degrees Celsius to 20 degrees Celsius. The temperature of the water flowing out of the heat exchanger will also drop by 40 degrees Celsius to 25 degrees Celsius. The sensor detects this, and as this temperature is below the proportional band, it directs the numerically actuated steam valve to open fully, as depicted here. As a result, the steam temperature is observed to increase from 70 degrees Celsius to 140 degrees Celsius almost instantaneously. What is the effect on the water temperature and the stability of the control system? To answer this question, we're going to use the heat and the steam load relationship. The heat exchanger temperature design constant can be calculated from the observed operating conditions as follows, where TdC is the temperature design constant of the heat exchanger, T sub S is the steam temperature, T sub 1 is the water inlet temperature, and T sub 2 is the water outlet temperature. In this example, the observed conditions at minimum load are as follows. We plug in our variables for a result of 2. When the returning water temperature drops to 20 degrees Celsius and the steam temperature rises to 140 degrees Celsius, it is possible to predict the outlet temperature of water from the heat load equation as follows. Here, T sub S equals 140 degrees Celsius, T sub 1 equals 20 degrees Celsius, TdC is constant equal to 2, so we plug in our variables for a result of 80 degrees Celsius. The heat exchanger new outlet temperature is 80 degrees Celsius, which is now above the proportional band, and the sensor now signals the controller to shut down the steam valve. The steam temperature falls rapidly, causing the outlet water temperature to fall, and the steam valve opens yet again. The system cycles around these temperatures until the control parameters are changed. These symptoms are referred to as hunting. The control valve and its controller are hunting to find a stable condition. In practice, however, other factors will add to the uncertainty of the situation, such as the system size and reaction to temperature change and the position of the sensor. Hunting of this type can cause premature wear of the system components, in particular valves and actuators, and can give very poor control.